This is the remainder theorem, and you're going to see why they call it the remainder theorem pretty quickly here. So we're going to do two things. We're going to find P of 3, like this. And plug that in our calculator to give us 30. And then we're going to divide this by x minus 3. We're going to use synthetic, so this would be positive 3 into, oh, what happened there? Into 1, 5, and 6. So that's 3. Multiply, that's 8. It's 24, and that's 30. Curious, right? That's 30. And that's 30. Let's try this again. So now we're going to plug in negative 4 to the same function. Plug that in our calculator. So P of negative 4 is 2. So now we'll do the same thing. We're going to take x plus 4 and divide it into x squared plus 5x plus 6. Use synthetic, so that's negative 4, 1, 5, 6. Oh, I was supposed to do blue. Now it's blue. Bring down the 1. It's negative 4. It's negative 4. And oh my god, it's 2 again. This is pretty interesting. So you can probably see why they call it the remainder theorem. So what happens here is if you plug in negative 4 or you divide by the factored form of the polynomial that gives us that 0, the factor, the remainder will equal the value. See what I'm getting at? So if you divide this by x plus 4, then we know that if you plugged a negative 4 into the function, it would be the same as the remainder. So if you have a polynomial p of x and it's divided by x minus k, then the remainder is equal to p of k. See how it's the opposite sign? Because remember, these are your zeros. If I plug in 4, 4 minus 4, right? If I plug negative 4 in here, we get 0. If I plug 3 in here, we get 0. So if it's x minus 4 is divided, the remainder is going to be equal to p of 4. If you divide by x plus 5, the remainder will equal p of negative 5. So if we want to find p of 0.5, then all you have to do is take 0.5, again that's supposed to be blue, and divide it synthetically. So remember, we're dividing by x minus 0.5, so when you use synthetic, it would be 0.5. So you use the same number. If it's 0.5, you use 0.5. So that's 1. And then 5.5 times 5 is 2.75. So that's 8.75. So now we know that P of 0.5 would be 8.75. And we can check that very quickly. Plugging that in our calculator. We get 8.75. Same answer. What's amazing. So if you want to find P of 0.5, you now have two options. You can just use synthetic using the same number, or you can plug it in. I actually like this method a lot better, and you're going to see the benefit of it when we start using this method in our polynomial sections. So that's the whole remainder theorem, is that when you divide by this, the number that makes this 0 will be the value of our polynomial. The remainder will be the value of the polynomial.